Hello, and we are live. So, hello, welcome. With this channel, I'm planning to create a community around data engineering and topics related to data engineering, connecting with experts or mid-level people, or even people who are just starting out and have interest in this community. So, this is an honest attempt towards having all the people, all more folks related to data engineering come together and sort of build this community around. And I found a way to start off this with Apache Kafka. So in this session, we'll just go over like what is Kafka and how companies might be using it, what are the use cases, and where how we can play around with it for now. So I'll just minimize this for a while. um, so Kafka is basically a event streaming platform that is used by thousands of companies, as it says in the description on Apache Kafka's official website. um, so the way it works is it is like essentially a logging system, in my opinion. So you just basically, as you go through it, you'll realize that there are a few concepts related to Kafka, and one of them is like producer, and another one is consumer. There's zookeeper, and there are brokers, and there are topics, a lot of stuff related to what Kafka is. So we'll just we'll just try to lay that out on a canvas and see how we can basically do visualize this. What can I do? I can just open another page and let's see if we have Kafka here. Okay, I think we can just copy paste from here for now. So imagine this as like the whole system of Kafka, and the way you can interact with this is through um, basically getting the yeah so the way you can interact with this is through writing some applications, or there are Confluent tools provided by um, the open source community, which you can directly use as a proof of concept to publish and consume messages from Kafka. So this is Kafka. So we can have an application here. Let's say Kubernetes. Let's say this is our producer for now. Let's give this name. Let's give this as producer. And so what you can do with this producer is you can publish messages to Kafka, and then on the other side you can, I think, receive the messages from Kafka, and which is called consumer. Now the consumer can also be the producer as well, and this producer can also be the consumer, but we will dive into that later. But for now, I think let's say you typed in you basically produced a message on Kafka saying, hey, hello plumber, and the way it will be seen is basically as you, these are active applications. So the way you will see is, oh sorry, the when you do this, Kafka sends the consumer uh, hello code plumber, and after this what you can do is and as you keep on sending these messages here, the consumer will keep receiving the benefit that you get, as opposed to, let's say, if you have one service, that is service 1, and so let's say you have this. Now you want to interact with from service 1 to service 2, and let's say they are maybe REST APIs, and service 1 interacts with service 2. Now this service ran into some issue and the requests keep coming to service 1. Let's say this is our if we are working with let's say travel platform. So let's say if this is the what would be a good example? So I think a good way would be, let's say this is a payment team in an e-commerce setting, and um, let's say this is an order team in e-commerce setting, and they call this service from payment team uh, directly, and there are hundreds and thousands of requests coming to this order team directly from the front end of the application. Let's say if this is the front end of the application. So if you write this, let's say you have like a lot of requests coming in, and so multiple requests coming in from front end, and saying that, hey, the calculate this, calculate that, and whatnot. And this order team is trying to this service is calling payment teams for all these calls, and let's say there, and for some reason, let's say the payment team goes down, the server from the payment team goes down because there are just too many calls to be handled, and it ran out of memory, or any unforeseen circumstances. So what you can do is you can have an event driven system, either a Kafka or RabbitMQ, or there are like a lot of frameworks to do this, to solve this. Each has its own use case, and there are trade-offs, of course. But what you can do is you can decouple this service and this service by introducing Kafka, where this service makes a request and it just queues up into this topic, and as the payment team starts consuming, becomes a consumer for Kafka for those events, it start doing its job. The benefit you get is the order team does not have to waste its resources until it waits for the response from payment team. It can just asynchronously process messages, and payment team can asynchronously receive requests on the other hand. So I think that's the benefit that you get, and plus there are hundreds of benefits in data engineering world, especially when you are working on large scale data sets, and you have to find an easy way to move around data within your organization. So I think that's where the Kafka plays a one of the major roles for sure. Um, what else? Yeah, so this is done. Apart from this, there are a lot of important concepts regarding the Kafka itself. I think the way it works is basically you you have topics in the Kafka. So let's explore documentation and key concepts. So let's go with the use cases. They might have, yeah. So you have messaging, then you have website activity tracking, metrics, log aggregation, stream processing, event sourcing, and I think data engineering has like a lot of good use cases for Kafka, like with this event streaming, event processing, and we have commit logs. Um, then it describes how you can quickly set up the ecosystem, but we'll jump on to the sorry, the key concepts first. So what is event streaming? So they have nicely described as digital equivalent of human body's central nervous system. And what can I use streaming for? So there are multiple use cases. Main concepts and terminology, I think this is important one. So yes, so there are topics, and there are of course this you if you run this in a distributed manner, you will have multiple partitions per topic. So by what I mean is, let's say you publish hello code plumber on Kafka, but you have to do it on a topic. So let's say if this topic is test topic, let's say, for example, and just so let's say if you publish it on the test topic, now this test topic, how it looks is, so you have something known as brokers, which are basically machines, and you have zookeeper as well. I think they are going to get rid of zookeeper, correct me if I'm wrong, but I think from the next iteration onwards they are thinking of removing the zookeeper from the very beginning. And so these topics, they are present in, I think, brokers. Let's go quickly through this. So, and every event will have key, value, timestamp, when the message was published, like a metadata. And in Kafka, producers and fully decoupled and agnostic of each other, which we already went through. Events are organized and durably stored in topics. Very simplified, a topic is similar to a folder in a file system. So yeah, that's exactly what it is. So let's say if we are producing the messages to test topic, then what it does is, I think, it will just create this file within the broker where you just where it just logs everything, and the way it keeps track of messages is through offsets. Offsets is nothing but a number that is used to track the event, like which consumer basically has consumed up till what. So let's say if you sent hello code plumber around, let's say, 8 a.m., then you published another hello code plumber 2 on 9 a.m. So consumer received hello code plumber at 8 a.m. and then he has to know, this consumer has to know that, okay, what's the next offset that I'm going to consume. So it will mark this as consumed basically through offset. So it will move its offset in the metadata as 2. So the next offset, when you publish the next message, its offset in the broker would be 2 within the topic, and this will resume consuming from the next offset. So, and you can also configure it to start all the way from the beginning. That's also something you can do. So yeah, to make your data fault tolerant and highly available, every topic can be replicated even across geo regions or data centers, so that there are always multiple brokers that have copy of the data just in case. um, that's true. So what you can do is to launch it in multiple locations. I don't know right now, I think it's not possible with the managed services, but theoretically you can do it if you're launching your own Kafka cluster and managing like a self-hosted one on AWS. I don't know if in this reInvent will they launch another one, but in case of topics, so this is precisely what the structure looks like. So I'm just going to zoom in a little bit and try to elaborate. So in one topic you have multiple partitions, so that let's say if you are processing the data to from order to payment in our use case here in an example. So here oops, it's just a little too much. Yeah. So let's say in this case, if the order team bombards the payment team with a lot of requests, even if there is just one topic, it will be flooded with requests. So if you have multiple instances of payment team, so what you can do is you can run this whole thing in a distributed manner, where you in your one topic, let's say in this case test, or in this case maybe order payment topic, I don't know. So in that case you can launch number of partitions, and what this producer will do, which is order team in this case, or producer will do, is find a partition either based on a key, or which will kind of guarantee the ordering. If you don't provide a key, the ordering won't be guaranteed. And so the benefit you get is, you let's say order team wants to send a sequence of events, or um, let's say if you are logging, in this case you are logging the vehicles data, with the same, like you're getting the vehicle data from all the cameras, let's say on the traffic signal. So you want to publish, like you want to know how the car went from which checkpoints. I think this is a good example. So you want to get the events in the sequence, how the car went. So let's say what is unique about the car. So the unique thing about car would be its license plate number. So to so if you key the messages by license plate number, what will be ensured is that every time the car passes through any checkpoint, the producer or the application, it publishes the messages to the exact same partition, and when you consume from those partitions, you will receive all the data in the same order. And if you just look at that data, that's how your car went through, like that's how you can track basically any car with a license plate, let's say XYZ. So I think that's a good example to sort of understand why why attaching a key matters. And it's good if you can group events by one concept. In this case, let's say there is a license plate, um, or in case of in case of in case of mobile, I think it would be all the events. If you have to track from a mobile, it may be the MAC address, um, or the IMEI number, or I don't know, but I think that sets the case for this partition. And setting key, assigning a key, so yeah, same event key like customer or vehicle ID will ensure that the ordering is maintained in one particular partition. Now this partition, these all partitions, if you have only single machine running for this Kafka, it would still be present in just one particular machine. If that's an EC2 instance on AWS, or have on-prem, but it's still one machine. What if that goes down? Then you basically lose that the whole topic's data. So to counter that, I think when you launch it with multiple machines and run within the distributed settings, so every topic can be replicated across geo regions or data centers. So if you launch like one EC2 instances, US East 1, one in US East 2, or US West 1, so every topics, each partitions will be replicated on every node, I think. And so so that there are always multiple brokers that have a copy of data just in case things go wrong. So you want to do maintenance on the brokers and so on. So the replication factor, I think in production setting, is recommended to 3. You can set it to maybe 5, I guess, if you want to basically design a fault tolerant, like you can increase that, but it will ensure that, just make sure that it will also increase your latency, because before this consumer can consume the topic, like the message from the topic, this message needs to be replicated across the many machines, and by a replication factor of 3 into all that replicas in the partitions on different machines. So until that, your consumer is not ready to receive the message, basically. So there's a trade-off of basically super fault tolerant versus the latency and performance and all that sort of things. So I think this sums up like how it basically operates. And I think they have a lot of like APIs and libraries and all the languages to basically publish messages. We can go over a message structure if so I think you can have like, I think you can have headers, then you can have key and then value, and you can also publish it through schema, which we can look once we as we progress, basically. But key and value, let's say, what would a good example would be? I'm just thinking, let's say you want to trace like all the cars that were Toyota Corolla, and I don't know if that would be a good example, but let's just think out loud. Let's say headers, you would define something as brand, so you write Toyota, let's say. And then let's say if you want to register event type, track, let's say something like this. So in the key, what you would give is maybe you can also use the timestamp from the same concept, but you can also use timestamp in the key itself. So let's say you register a vehicle. So if you store vehicle ID as LMN2456459, and then you could, in that value, you could basically write, let's say, where did the vehicle pass from, and the location, let's say location ID, and it's 123, and let's say that's the only value you care about, or the uh, type, it would be SUV, and so the timestamp that will be attached to the message by itself will be the timestamp that was that when the message was published. But let's say if you want to record when that vehicle passed through a particular location ID, then you would also include the timestamp of the passage. Let's say on February what's the date today, 9th. So February 9th, you, and at 12:29, and you can go as granular as you like. So basically that's the value, and the timestamp, let's say it got published in after, it took like 5 seconds to get published to so I'll just say okay 10 seconds, and then on timestamp I'll just oops, I can just say this, I can increment this by 5 seconds. So I think this looks like a good event to consider. I'll just remove the whole and convert that to 12, maybe, no, maybe more. Okay, okay, so this gets published to test topic, I think, and you can do basically anything that you like after this, and you can play around with the data. So yeah, this is just a basic introduction of how Kafka looks like. There's a whole lot of tooling around Kafka, and I'll be exploring some of them for sure, and try to create this locally. Yeah, so thank you for today's session, and I'll see you in the next one. Let me know if you have any feedback. I have mentioned the links where you can connect with me. Instagram, LinkedIn. I have also created a Discord channel where I appreciate people joining and basically pitching in the basically the knowledge they have, and seeking out any answers to any questions they have lingering in their head regarding any topic related to data, and I'll try to reply, and people who are experts can also pitch in and sort of create this community together.